Yeah, hello and welcome everybody. Thanks a lot to the organizers for giving me the opportunity to present my work. Thanks for tuning in. And yeah, as Bernhard already said, it's about market transparency and consumer search, some evidence from the German market. So what's this all about? Well, first of all, arguably market transparency is and it has been quite a relevant policy issue in various jurisdictions. Okay, so that is reflected, for instance, in the G20 high-level principles on financial consumer protection. This is also reflected in the EU price indication directive, where basically people state that we need transparency in order to improve consumer information and subsequently facilitate comparison of prices. Okay, now on top of just saying that it would be a great thing to have more transparency in the in some of these markets, some jurisdictions have gone even one step further and initiated some transparency initiatives themselves. For instance, they have started enacting government-operated comparison websites. Okay, we see this, for instance, for financial products, for energy markets, and is most relevant for my today's talk in retail gasoline markets. And we see some of these government-operated comparison websites, for instance, in Germany, France, and Austria. Okay, so but given that we see or we hear the policymakers are saying that this would be a great thing to have, and also taking some initiatives themselves, this triggers a fairly relevant question to ask, namely whether these policies are any effective in promoting competition and increasing consumer welfare. Okay, so this is the stated objective. So I guess it is fair to ask whether these policies are any effective in delivering what they are supposed to deliver. And the application that I will present today is, from my point of view, a fairly ideal application to consider these questions. And it is framed within the setting of retail gasoline markets. Why is this such an ideal application? Well, the first reason is that we have fairly good hope to estimate and quantify the degree of differentiation in these markets in a fairly convincing way. This is much more difficult in some of the other industries, and I will try to convince you that in the retail gasoline market, this is indeed, given the data and given the approach that I'm using, fairly easily feasible. The second reason is that there is very interesting variation across countries about how exactly these transparency initiatives were implemented. In Germany and France, for instance, there is a regime in place which I will refer to as full transparency, and I will be more precise in a minute what it exactly mean with that. Whereas in Austria, in stark contrast to that, there's also a transparent government-operated website, but it is deliberately restricted by the government. In particular, only the cheapest prices are shown. So let me give you some example of what this looks like. Okay, suppose you want to fuel your car in somewhere in Germany, for instance, in Mannheim. Okay, and you have heard that there is this government-operated website. You can use it, on your computer, on your mobile phone. There are lots of apps, all of these things. You can just look it up, and you can look for gasoline stations close by and get real-time information about the precise price each of these gasoline stations close by are charging in this moment. By law, by regulation, all gasoline stations are obliged to transmit the prices to a government-operated database whenever they change them. And from there, this information, this real-time pricing information is accessible to consumers. Now notice that on this website for Mannheim or anywhere in Germany, you are given all the information that is stored in the central database. You can possibly learn about all the prices from all over Germany. By design, this environment is fully transparent. All the prices that are stored in the database, all the prices the government knows about, the respective agency, all of this information is possibly provided or made accessible to consumers. Now, in stark contrast to that, let's look at the comparable websites in Austria. Okay, so again, same story. Suppose you want to fuel your car, now for instance in Vienna. The basic regulation is the same. All gasoline stations have to transmit the prices to a central database. All the prices that are currently in place are stored there. But once you start looking up these prices on one of the websites, what you are shown is still an exhaustive list of all the stations that you could possibly be interested in. But you will learn about the prices only of the cheapest stations out of these. From the remaining stations, and it's always truncated to show you the cheapest 5 out of the 10 closest by stations. And for the remaining 5 stations, the 6th to 10th most expensive station, all the information you're given is that this station is currently not among the 5 cheapest. The price is stored there in the database, but it's deliberately, it's by design, not made accessible to consumers. And in that sense, in that vein, there's a restricted transparency regime in place. Okay. Now I will talk a bit more detail what's the background of this deliberate government restriction in Austria.
Simon,
yes.
Larry White has a question. What if there are multiple grades or qualities of gasoline?
Right. Okay. So basically, you can basically choose here between diesel and benzene. That is gasoline, and it's not differing among grades. Okay. So basically, it looks at all the prices that are in there, and basically you yourself you can filter for the grades that you're interested in, and then basically the filter, like to showing the cheapest, only applies for this particular grade that you're interested in. Okay.
Okay, great. Thank you. Thank you.
Sure. Okay, so and now what, theoretically speaking, I think such a deliberate restriction in transparency introduces several interesting trade-offs to be looked at. Okay, so we are starting with a baseline with a fully transparent environment. And now we are interested in what happens if we deliberately restrict transparency relative to that. That is informing consumers only about a subset of prices. Now, so what happens as far as prices are concerned is that on the one hand, consumers are able to compare only from a smaller set of alternatives. They can compare only less alternatives. And this allows the firms to possibly charge higher prices. So this may lead to higher prices. But on the other hand, and importantly, once gasoline stations understand that those consumers who query information online will possibly only consider them if they make it among the top 5 cheapest list, then there is an alternative channel for competition, namely competition for attention, competition in order to even make it for a spot on the list. And this leads to potential downward, this puts downward pressure on prices. So we have possibly with 2 countervailing effects, and it is ex ante unclear which of those 2 channels is stronger. So as far as prices are concerned, the net effect of a transparency restriction is ex ante unclear. That is as far as prices are concerned. What we're typically eventually interested in is not only prices, but also consumer welfare. You know, like matching needs to be efficient. A consumer needs to be able to find a gasoline station that is conveniently located, that provides lots of amenities that she could be interested in. So it's not only prices. It does not suffice to look at prices only when there is some degree of differentiation. And as far as consumer welfare is concerned, a restriction in transparency may lead to lower prices, as I have just argued, which is something that consumers would appreciate, of course. But this goes at the expense of less efficient inefficient matching, which reduces consumer welfare. So basically, we have an ambiguity, an ambiguous effect as far as prices are concerned, and also as far as the net effect on consumer welfare is concerned. So ex ante, it is not clear what such a transparency restriction actually delivers. Okay, so this brings me now.
Heiner Schumacher is wondering how many consumers are using these tools. You're talking about consumer surplus and
right. Okay, yes, that's a great question. So basically, I'm using kind of 2 sources of information concerning that. The first one is some surveys that were conducted by the German Bundeskartellamt. Now, you may have all kind of concerns about surveys and wonder to which extent these are accurate. So the second source of information that I'm using, and which I believe is like kind of by design much more accurate, is aggregate website usage statistics. So basically, I know how many consumers queried some of these websites in total. And both of these lead a fraction of around 20% of consumers using one of these websites at least occasionally. So basically kind of the figure, the ballpark that I'm aiming for is like around 20% of consumers deriving information online or deriving information about prices and subsequently basing the purchase decision on it. Okay, so the questions that I'm then asking here is, what is the effect of transparency in markets with these types of information frictions? And where I eventually want to go, and where I am actually going already with the paper, is to conduct some kind of counterfactual policy simulation. Namely, I'm asking what it would be the effect on prices and consumer welfare by changing the transparency regime in Germany. So basically in Germany, there's currently a fully transparent regime in place. And I'm asking what would happen if on these German websites, we would deliberately restrict transparency and show only a subset of prices. Okay, here are the main results that I find. First of all, and most importantly, I believe is that consumers can be better off with being given strictly less information, but importantly, not too little. Okay, so what I find is that showing only the top 20% of prices would be optimal in a consumer welfare sense. This would lead to consumers' expenditures decreasing by around 1.2% relative to the status quo. This is partially mitigated by the inefficient matching that I mentioned earlier. So in terms of consumer welfare, I would find that such a restriction in transparency would increase consumer welfare by the equivalent of around 3 to 4% of firms' current margins. Now you may wonder what maybe it would be in the consumer's interest to restrict information even further to show even less than 20%, maybe only the top 10% or whatever. Well, for this, I noticed that according to my estimates and my counterfactual simulation, the prices would indeed decrease further. But eventually the matching would become so inefficient. You know, if consumers can only find a very selected sample of stations in the market, the matching would be very inefficient. Maybe a consumer would find a station that is very cheap, but possibly very far away, or possibly not offering the kind of amenities that the consumer is interested in. So combining these different considerations, I find that consumer welfare is then inverse U-shaped in transparency. That is in terms of the key findings. Additionally, I think I also offer a methodological contribution by providing a framework that allows estimating discrete choice model with incomplete information and using pricing data only. That is, of course, a major challenge in my environment here, and I will tell you in a minute how I propose to overcome it. Okay. That's maybe a good point to maybe stop for questions again, or to see if there are any.
Well, I think you're good to go. All
right. Okay, so maybe let me just briefly mention in terms of related literature. It is true, of course, that since market transparency is somewhat prevalent in recent years, and that also this has triggered some empirical studies. But by design, most of these are diff-in-diff type of studies. So basically, they consider market outcomes before and after the introduction of some transparency intervention. So by design, they can only consider the two extremes of no versus full transparency. So by design, they're restricted not to kind of find what is eventually my finding, namely that an intermediate level of transparency would be consumer welfare optimal. Yeah, and maybe another thing, of course, there's like a very broad literature on gasoline prices altogether. For instance, also Montag and Winter about the German market, and also some fairly recent paper by Assad and then Erschkofer and others, which have started looking at algorithmic pricing in the German gasoline market, which might be the case, and they actually provide some evidence that this seems to be fairly widespread by now. But as far as my estimates are concerned, it does not really matter. I do not really take a position whether the prices by the end of the day are set by some humans or by some algorithms. So from my estimates, I think this does not play that big a role. So in terms of the approach, I will present a model which is broadly in this, at least in the spirit of variant models. So basically, I distinguish between some consumers who have obtained some information already and are not willing to obtain additional information, and some consumers who kind of query information online and then compare prices and do what's best for them. And in terms of the estimation routine, it's also based on the paper by Thomason, who presented an overview for the California fast food industry. And then basically, once I have this model, I estimate it structurally. I consider a setting with both horizontal and vertical differentiation. I understand that many people view gasoline as a fairly homogeneous product, which to some extent is true, but nevertheless, I'm quite convinced that there is both a horizontal and a vertical differentiation aspect. The horizontal aspect stemming from the fact that consumers may find it inconvenient to drive to a gasoline station which is very far away, which may in turn then be better for some other consumer. And also a vertical aspect, because a consumer may find additional amenities, possibility to wash the car or to purchase cola or whatever in the shop close by to the station. So from that point of view, I do believe that there's also this vertical aspect. And also there is a fairly high volatility in the market. So prices fluctuate quite heavily. The average station in Germany changes its prices 3 to 5 times a day. So, you know, there's really quite something going on in this market. I distinguish then between uninformed consumers and website consumers. Website consumers basically derive information online, and both types of consumers then make a discrete choice of the gasoline station that provides them with the highest utility given their consideration set. And then the transparency regulation affects the consideration set of those consumers who query information online, because it kind of shapes which set of station and which prices they're even informed about. I do not find actually evidence for mixed strategies. I basically construct the rank reversal test in the spirit of Chandra and Tapata. And given that, I find it natural to consider instead a game of incomplete information. So basically there are repeated shocks to the marginal costs, which then give rise in aggregates to uncertainty in prices in rankings. So, and if then a consumer at any point in time would know precisely which prices are currently in place, this might possibly influence their the purchase decision. In terms of estimation, I then provide a flexible two-stage approach, which is kind of similar to the approach that some of you may know from the auctions or dynamic games literature. And I proxy for demand using publicly available buildings data. I will show you in a minute how precisely I'm doing that. But really, like, one key challenge there is that I can easily find tons of price information. You know, I can basically use precisely those prices which are published on one of these websites. That's not a problem. But what is more problematic is getting access to market shares. So basically, you know, like some measure for quantities, how much a gasoline station sold at any point in time or a time span. So basically, I need to proxy for that somehow, and I'll do this using buildings data. So in terms of prices, the data that I'm using is the 2017 prices for entire Germany, and a focus on 5 p.m. on weekdays. So basically, that's you know, where most people fuel their cars. In terms of market definition, I delineate markets currently, at least on a municipality level, in order to get isolated markets. As you will see, this will be quite useful or indeed necessary for my counterfactual simulation, that I somehow can isolate markets in order to prevent all stations from eventually competing with each other. Now, obviously, there are some drawbacks to you know, like administrative boundaries, which are somewhat arbitrary, of course. So in ongoing work, I'm trying to delineate markets based on regional clusters instead, which is some kind of endogenous market delineation, but at the moment, it's still on a municipality level. And I focus attention to municipalities with at least 3 stations, and at most 315 out of these grid cells, which I will show you what precisely I mean with that. But this leaves me with around 9,000 stations in around 1,500 markets. Yeah, in the view of the algorithmic pricing considerations of Assad and others, I will also then separate the estimation only for the first half of 2017 before the algorithms started taking over in Germany. But again, from preliminary analysis, what I understand is that this doesn't make that big a difference. Then I enhance this data with some demographics from statistics agencies and the oil price, buildings data from OpenStreetMaps and this website usage statistics in order to get some idea about how many consumers are currently using that. Now about the buildings data, which I will use to proxy for demand somehow. The approach that I'm using here is the following. Okay, so consider here with me, a graph from the Bavarian village of Plattling. And in Plattling, there are 4 gasoline stations depicted by green pentagrams here. And yeah, they are somewhat located along the main roads, of course. Yeah. Okay, so that's my starting point. I have the entire map of Germany. I have the location of all the stations. Here are my 4 stations in Plattling. Now, from OpenStreetMaps, I can download and extract the exact building information. Okay, so kind of OpenStreetMaps comparable to Google Maps in many ways, but luckily being more easier accessible. So basically, I know where all buildings in Plattling and similarly all over Germany are located. Okay. Now I have the information about the gasoline stations and about the buildings. Now I can compute the total area of each building and put this in relation to the total area of the entire municipality. And then I can kind of distribute consumers geographically all over the village by making the third step here, which is throwing an artificial fishnet all over Germany. An artificial fishnet which separates entire Germany into 1 kilometer times 1 kilometer large grid cells. And based on the proportional buildings area, I can compute how many consumers more or less are supposed to reside in each of these small grid cells. Okay, so what I have color coded here is basically according to the implied population density in each of these grid cells. And now I have lots of grid cells, fairly detailed. Now from each of these grid cells, I can then compute the distance to each of the gasoline stations. And then once I subsequently estimate some distance disutility, I can estimate the implied demand from each of these grid cells, and I can get some measure for the total demand for each gasoline station by basically summing up a weighted average from all of these grid cells. Okay, so that is basically how I overcome this this challenge that I do not have like direct market shares. Obviously, it would be preferable if I had them. I do not, so this is an alternative approach that I think still works reasonably well. Okay, so once I have this, I can now give you some idea what exactly my model looks like that I eventually take to the data. So in total, I consider a set of geographic markets M, each of which consists of up to n stations. And then the indirect utility of some consumer I living somewhere in this market from some firm J in this market consists of the following components. First of all, some brand specific components. So, there could be systematic differences in the consumer valuations of different brands. Secondly, consumers do not like driving. They have a disutility for a gasoline station that is further away from them. Okay, so basically this is this distance Dij multiplied with some delta, and this delta is some parameter that I will estimate. So basically I will get some idea how much consumers dislike driving. Then of course consumers also don't like high prices, so there's some gamma times PJ, and on top of that there's a type 1 extreme value shock. So given that, combining these, this then gives rise to a standard logit demand given a consumer's consideration set. Now, as I said, I distinguish between two types of consumers. Loyal consumers, that is, like, think about it, of like around 80% of consumers, they learn or they consider only one station close by, or you think about of the habitual consumer who has been shopping and fueling his car for the last 10 years at the same station. He just keeps doing the same thing. Now, in contrast to that, there's website consumers who look up information online and they learn the K cheapest prices from this market online, where K is basically the seedling of rho times N, and where I interpret the transparency regime rho as the fraction of stations that these consumers can possibly consider. Now, in the baseline case in Germany, rho would be 1. In Austria, it would be 1/2. But so what I will use for estimates is rho equals 1. The website consumers can learn all the prices online, and this is the parameter that I will tweak for my counterfactual analysis. And then, yeah, basically what I'm assuming is that, given all my grid cells, basically I assume that consumers live in the centroid of each of these grid cells. Okay. Now, this was the demand side. Now let's look at the supply side. Now, consider some form I, which lives somewhere in this market, and the total demand that this firm faces is then the weighted sum over all the grid cells in this market. So basically, there's some measure for the population density, kappa B, that is basically what I constructed out of my fishnet and cells type of approach. And then in each of these grid cells, there is this fraction of website consumers, which has some demand, and a fraction of loyal consumers, which have also some kind of demand, where the demand from the loyal consumers depends only on its current on price, whereas the demand from the website consumers depends on the entire vector of prices, because this then in turn influences, first of all, whether the focal station I can be considered to start with, if it made it to the top spots on the list, and additionally, if it was sufficiently cheap such that it provided the highest utility. And then firms compete in prices. So I guess this is like the usual idea here. But what is maybe a bit unusual relative to Varian and other models that generate price dispersion is that I will cast this as a model of incomplete information. So basically there is the total marginal cost that a gasoline station faces consists of 3 parts. There is a commonly known part, which is first of all some chain specific part, which is like the CK here. Okay, so I will estimate that, like as what you usually do. You estimate some measure for costs, and this I consider it as a brand specific cost. That is my CK. Then there is also a common cost, that is CA. Think about as the oil price, and those 2 parts are commonly known. All the firms in the industry know it. The common cost and the chain cost are commonly known. But on top of that, whenever firms set prices, there is some additional shock epsilon I, which is private in information, and this then shapes this firm's decision to charge certain prices. And all of this is then multiplied with some expected demand expression. So basically, since this is cast as a game of incomplete information, the firm also does not know which prices its competitors are charging at any given point in time. So it has some expectation over it. Okay, then basically from this I can derive the first order condition. I can write this in vector notation, but crucially, I can basically then solve this for this some epsilon for the marginal cost shock, which will be the objects that I will then use in my subsequent GMM estimation. Okay, before I go to estimations, maybe another good point to stop and see if there are any questions.
That's perfect. We have two demand-related questions. One's by Heiner Schumacher. He's wondering, given that people visit a gas station when they return from work or from a trip or from the supermarket shopping, why do you use the location where people live? First
right.
question.
Okay. Yeah. Okay. That's a good point. Absolutely. So I'm, like that's detailed data about how and where and when exactly people commute, unfortunately, is not available at this fine granularity that I would require it here. Okay, so I understand there's some papers that have used and some commuting data, but I think it's on the granularity that I would require here. To my understanding, it's not available. And secondly, like the buildings information that I'm using here does actually not distinguish between the type of a building. So in some, I cannot identify whether this is a residential building or an office building or a factory. Okay. So, and all of these are part of my buildings. So in some way, I think this does also take into account that certain buildings, certain areas is not where people actually live, but where they work. So in that sense, I think this would also be would also influence my demand estimates. So yeah, I think given the data that I have, that's the best I can do, but I think it's actually still quite reasonable.
Thanks. And another question by Ilona. What is the outside good in your setting, and do you assume it is located in the location of the consumer?
Right. So basically, the outside or the share of the outside option. I mean, I would think about it here as like just not fueling your car at that point in time. You could think about it as using public transport instead, or cycling instead, or just not using your car, not fueling your car on that day at all. Now I use an aggregate for the outside option because basically I don't have any good idea or any good means of like regionally differentiating between them. So in some sense, I assume that this is the same across markets, which may not be ideal, but I think, again, given the data that I have, I think that's the best I can do.
Thanks.
Simon, you're good to go.
Okay, fine. All right, so basically then, I can back out the epsilons, my marginal cost shocks, as a function of the primitives of the model and as a function of the observables and crucially also the parameters that I will estimate. So basically, I employ a two-stage approach here. In the first step, I estimate the firm-specific price distributions. So, that's something, I observed that all the prices, basically I can fit the log normal distribution through this conditional on the oil price. And then I can plug these estimated price distributions into the other firms' first order conditions. So basically, I can derive some epsilon hat, which is implied by the data and my parameter vector theta. Then I can interact this epsilon vector with my instruments and like estimate the parameters as usual with GMM. What I do need to fix upfront, I think we brought that up already, is there's two parameters that are not identified within the model, so I need to somewhat fix them upfront. And the first one is the fraction of informed consumers or the fraction of website consumers, which according to my website usage statistics estimates are around 20%. And I also need to fix the market share of the inside goods. Okay, so or alternatively fixing the market share of the outside good. So that according to aggregate consumption statistics, I fix this to be around 92%, and I conduct various robustness checks for both of these. Right. Yeah, so then in terms of identification, yeah, as I said, the major challenge here is that I do not have any market shares. So basically, I borrow this approach by Ralph Tomlinson, and I assume that the mean utilities per brand are the same across markets. Now maybe let's just briefly go back again. So what you would usually do in supply and demand estimation is that, basically this is from this supply relation here, we could possibly identify the supply parameters. Then we would additionally require some kind of demand relation from which we would require estimate the demand parameters. Now all of this is combined into one single equation. Okay, so basically from this equation here, I attempt to simultaneously estimate supply and demand, which one may think could be fairly challenging, and indeed it is. But once we're willing to make the assumption that the mean utilities per brand are the same across markets, and we take advantage of the fact that the same configuration of brands are observed on the different market configurations. So, think about it that, we have one market in which there's only 2 stations, possibly of differing brands, and we have another market which consists of up to 3 stations. Well, how firms find it optimal to set the prices differently in those 2 markets tells us something not only about the supply side parameters, but simultaneously also about the other side. Okay, so once we make this assumption, we can simultaneously, based on only one equation, and if there's sufficiently non-linearity in all of these terms, can simultaneously estimate supply and demand. Now, what I have actually on top of that is also variation of prices over time, which makes it even easier. But then in a nutshell, what I'm exploiting here is the variation in the geospatial market structure and also in the input prices. And this then allows to estimate supply and demand simultaneously based on one equation only. Okay.
Before you look at the estimation results, Larry White with a question on the data on the buildings. Is it just the existence of the building or the area? This seems to be a critical factor.
Is it just exist? Right. So I observe the set of all the buildings and I can compute its ground area. I do not observe its height, so I cannot compute the volume, but I can compute its ground area. So it's not only here is one building and here is another one, but I basically account for the size, for the relative size, total area of all the buildings. Yeah.
Okay. Thank you.
Sure. All right. Okay. So basically, yeah, once I have this, basically I can estimate my demand and supply side parameters. So basically I can estimate my price sensitivity. I can estimate my distance disutility, and I can also estimate the brand specific utility terms and the brand specific cost terms. Now, instead of looking at these figures, let's maybe just briefly consider what they would imply. Now, suppose there is an Aral station which is charging a price of 120 cents, like €1 and 20 cents. At which price would a consumer which is located at equal distance to some of these other stations, when would this consumer be indifferent between fueling the car at 120 cents with an Aral station, or at some other price at some station of some other brand? Okay, and the price that would make the consumer indifferent, for instance, with fueling at the Shell station, is slightly below that, which basically is telling us, I mean, this difference between Aral and Shell is actually quite small here, but this would basically tell us that, that this consumer still would value fueling at the Aral station more than at the Shell station, and definitely much more than an other unbranded station. So in order to be indifferent, this other unbranded station would be required to charge a price of 118 cents instead. Okay, so basically also from these estimates, we can somewhat see that there is indeed this vertical differentiation aspect also reflected in the parameter estimates. And from this, you can already get some idea how or when some transparency technology could possibly lead to inefficient matching. Okay, so if consumers are being given less information, then possibly they end up with a station that is much cheaper, but something that provides them with quite a bit less utility. Okay, and that is something that we will need to consider in our consumer welfare calculations.
Do you have outside information, like survey information, on how consumers view these different brands? So this vertical differentiation, is this something that we actually see from evidence outside your own paper?
Right. Okay, that's a good question. I'm not aware of like any surveys which are supposed to rank brands, but that's actually a good point. Maybe I should look that up if that is also available somewhere. Like from my intuition, I think this, or from like kind of anecdotal evidence, what I heard, this sounds to be somewhat accurate, but in terms of survey, yeah, I'm not aware of any at the moment. I should look it up. Thank you.
And these are estimated in different prices. Do they somehow also relate with the average prices of gasoline at these gas stations? Like, are Shell stations also, in fact, more expensive than total Esso and jet stations in sort of that order?
I think also, like, by and large, I think that is indeed the case, but that's again, yeah, good point. Would be maybe interesting to contrast this also on this graph here again. Yeah, thanks. I'll write down. Yeah. Right. Okay, so once I have this, I validate my model. I think this is quite relevant in particular in structural estimation. You may have all kind of concerns or wonder whether this somewhat sophisticated model actually adequately reflects what's going on in this industry. So I think it's quite important and useful to do some kind of validation exercise. And what I'm doing here is basically looking at observed versus computed prices. So, once I have these parameter estimates, I can basically compute, assuming a certain equilibrium and assuming the estimated parameters, I can compute the implied prices and contrast these with each other. And I can do this in sample, that is using prices that are used during my estimation, and also out of sample. I have not used all the pricing information that I have for my estimation. So basically I can also do this out of sample. And for both of these, I actually find a very good model fit. So basically my implied prices are fairly close to the ones that I actually observe, both in and out of sample. Right, and once I've done this, I can then basically start computing all kinds of counterfactuals. So basically, in the baseline case, what is currently in place in Germany is a fully transparent environment. That is my rho parameter equals 1. That's what I use during estimation. Now I can compute and conduct all kinds of counterfactuals. So basically now I can reduce the transparency regime so that's those consumers who query information online, website consumers, so that they can only learn a subset of prices. Okay. And then again, I can basically compute the equilibrium outcomes for both scenarios, and I need then, of course, to compute the confidence intervals accordingly. What I am currently not yet doing, and basically, again, this is driven by data necessity, is that I do not allow a higher or lower fraction of consumers to endogenously use some of these websites. Okay, so basically when I reduce the transparency regime, I assume that the 20% of consumers who use the website remain fixed. Okay, because basically, given the data I have, I cannot really endogenize a consumer's decision to query information online. Anyhow, given that, well, I find all kind of interesting outcomes, but I will not go in detail here, but instead show or explain through some graph. So basically, what I'm depicting here is prices and consumer welfare depending on transparency, or as a function of the transparency regime. So basically, in our baseline case, according to what we started estimating, we're at the very right part here, transparency rho equals 1, a fully transparent environment. Now, consider with me, first of all, the effect on prices as transparency is reduced. Okay, prices is the dashed dotted line here, depicted on the left y-axis. And basically what we see is that the implied average posted prices decrease as transparency is reduced. Okay, so basically what this is telling us is that the aforementioned attention effect is so strong that when consumers are informed only about a smaller subset of options, firms understand that they need to compete more fiercely, they need to compete stronger in order to even appear on the list of options, in order to even make it to a consumer's consideration set. And this effect is sufficiently strong in this environment such that prices decrease when transparency decreases. That is, first of all, observed prices. Now, and I think that's actually also one kind of shortcoming of several other papers, is that they all consider posted prices only. But I think actually what is the more relevant measure is the quantity weighted price, the price at which consumers actually purchase. Because, you know, if a price becomes super low, but no consumer can find it, then this is not very, very much helpful to them. So this is what I'm depicting here as the weighted price, that is the dashed line, which is all for any transparency regime considerably lower than the posted price, because consumers more proportionally fuel the cars and hence have higher demand for lower prices. And this also decreases quite substantially when transparency decreases. Okay, so from that point of view, this may already suggest that it is in the consumer's interest to have less transparency, a less transparent regime. Now, let's consider also consumer welfare on top of that, which is depicted on the right y-axis and as a solid line. What we find here, starting from a fully transparent environment where rho equals 1, this consumer welfare increases when we decrease transparency. So basically, consumers initially like the fact a lot that prices decrease, and they do not yet mind that much about also accomplishing decrease in matching efficiency. Consumer welfare increases further and further as we decrease transparency, up to a point of a transparency regime of rho around 0.2, showing around the top 20% of prices. In that case, prices are quite low, and also the matching is still relatively okay. What we also find, if we then would decrease transparency even further relative to that, to a transparency level of around 0.1, showing only 10% of prices, this would really harm consumers, because now, although the prices are still getting lower, but also the matching becomes very inefficient. Consumers basically don't find the most preferred options at all anymore, or they need to travel very far to the cheapest station. Okay, so basically, from combining these aspects, there is this inverse U-shaped relationship between transparency and consumer welfare. Okay, now, Bernhard, how am I doing on time? Okay.
You have about 10 minutes. You're doing all right. Yes.
Oh, perfect. Okay. Fine. Okay, so then I can actually also talk a bit about this other counterfactual that I'm considering here. So basically, what I just showed you was some deliberate reduction in the transparency regime. That is something that the government could tweak fairly easily. You know, like it could basically pass a law that says, well, one can show, or on these websites only the cheapest 20% or so of prices shall be shown. What alternatively the government could also try to influence is convincing consumers that it might be in their interest to look up query information online. So basically the counterfactual that I'm showing here is tweaking the fraction of informed consumers, tweaking the fraction of consumers who look up information online and hence induce firms to price competitively. Now in the baseline case, currently, according to my estimates, there's around 20% of informed consumers. Now, if we manage to convince a bit more consumers, if we had a higher fraction of informed consumers, then prices would go down. Okay, you know, so basically there would be more pressure on firms to charge low prices, because more and more consumers, it would become relatively more attractive because more and more consumers would basically look it up and find them, and consumer welfare would unambiguously increase here. Now, I have to qualify this statement with the following, that this does not yet take into account potential inconvenience of or like some kind of search cost for the consumers to look up information. So this is only as far as consumer welfare is derived from your gasoline purchase decision. You know, since I basically don't really have an endogenous search decision here, I also don't have like really a possibility for a disutility of searching or some search cost estimate. So basically, this would still have to be subtracted from this consumer welfare calculation here. But you know, as long as this is within reasonable bounds, I think the net effect on consumer welfare would still remain positive. And this effect here would actually be much stronger than the effects that one could potentially derive from tweaking the transparency regime. Okay, so what would be the most effective way of getting to lower prices would be to convince lots and lots of consumers to use some of these price comparison websites or apps, but this is probably much harder to achieve than just a change in the transparency reduction. Okay, so with this in mind, let me conclude here. So basically, my main finding here is that the transparency regulation needs to consider the firm's equilibrium response to the transparency regime. And here in particular, this means the incentives to be displayed to get even the possibility to promote the price. But in doing so, the transparency regulation also needs to strike a trade-off with matching efficiency. Okay, so yes, it is true that firms will start pricing more competitively when transparency is reduced, but matching becomes possibly inefficient, which consumers may not appreciate. So from that point of view, theoretically restricting transparency may lead to lower prices. And indeed, what I find empirically that in Germany, restricting transparency to showing only the top 20% of prices decreases the weighted prices by around 1.2%. So this shows that the attention effect, the effect of inducing firms to make it to the list, this is really something relevant. But this effect is partially mitigated by the less efficient matching aspect. And I think the methodology that I'm proposing here, so basically estimating based on prices only, using this publicly available buildings information, I think this is somewhat novel and potentially also applicable to numerous other settings in which the geospatial market structure plays a relevant role. And yeah, with this, I would like to close and thank you very much, and looking forward to some more question and discussion.